Hello, dear listeners. Welcome to Semaphore Uncut, a podcast for developers about building great products. In this new episode, Darko, the podcast host, welcomes ControlPlane founder and CEO Andrew Martin. Andrew shares his expertise in software, cloud, open source supply chain, and AI security. I hope you enjoy this new episode, and let's dive in.
Today with us, we have Andy Martin. Andy, thank you so much for joining us.
Thank you for having me.
Great. Can you please just go ahead and introduce yourself?
I am Andy, founder and CEO at ControlPlane. We are a cloud-native security consultancy focused on regulated industries, financial services, government, and anywhere who knows that security is a problem.
Semaphore has released the Flaky Test Dashboard to help you identify unreliable tests in your project. Identify which tests disrupt your pipeline and cost you the most, all in one place. Go to semaphoreCI.com/product/flaky-tests-dashboard to find out more.
Can you give us some, stepping stones through your career? How I ended up doing that? I guess you didn't walk out of university and say, I want to do security for government.
No, it's not the easiest transition to make. You're correct. I began with a straight-up computer science degree. After I finished university, I was looking for a job where I could work with a collection of computers, and I ended up in a startup in Bristol. And I had the very privileged position of being able to analyze not only how to evolve the development of the system from basically just a MySQL 4 LAMP stack into what became a service-oriented architecture, enterprise service bus, all the Java services, all that good stuff, and then got involved in what became configuration management and DevOps. Then I moved to London to move into consultancy, and because as part of my placement year, I'd worked for the RAF. So I got to go to a third of all the RAF bases. They sign you in, and that adjacency to how the mechanics of things work beyond the visible. I've been working with Docker containers since about 2014-15. So bet everything on Kubernetes, started a consultancy in 2017. We now have 60 people across 12 countries. Really, really huge and wonderful fun.
Amazing. Can you speak? What are the main things that your customers are seeing, and how you guys are helping them?
When people ask me, what do you do? What actually is security? What are you doing? My answer is always, it's just DevOps with security requirements as acceptance criteria. Mapping systemic threats back to existential business risks is the way that we actually convince stakeholders that there is a problem here, and it's not just people who like to make noise about security. The whole DevOps movement was bringing development practices to operations people, and we had the huge problem of course, everybody who was a system administrator suddenly became a DevOps. Fundamentally, everything is built on that baseline of being a full stack, full spectrum thinking individual. And honestly, that normally stops a browser delivery. For everything we do, we focus on getting something out of the load balancer rather than looking at application level security. So that is still one of the biggest problems. The most common cause of cloud insecurity is misconfiguration. And so having pipelines that build out all that good DevSecOps stuff, if we're going to do unit testing for application code, well, then we should be doing linting and some form of value analysis for the YAML that we throw at Kubernetes. But then on top of that, you have that very good baseline of engineering. You have a security team or champion that can help to threat model, bring all the stakeholders together so that it's clear multiple different views are being respected and it's not just minimum path to production. And then find those acceptance criteria. And at that point, we've hopefully got something that is correctly deployed. Now, at that stage, we then need to worry about the software composition. So if we know that we're deploying things in a secure manner, we're using best practice for where networks configured and segregated, microsegmentation for the actual applications themselves, best practice secure by default deployments of infrastructure as code modules, and scanning everything in the pipeline for preventative measures and also checking that they've been deployed for dynamic measures afterwards. At that point, we have to worry, well, what's in the applications that we're deploying? And as I said, ControlPlane doesn't involve themselves or ourselves so much in the application security realm. We just assume breach. We assume that the application is compromised, and then the topology of the application that's being built is then built with resilience in mind. This comes at some cost because, of course, whatever you choose to do in there comes at some cost of complexity, maintenance, the runtime latency, the actual compute to do the thing. My favorite thing is trying to build a system that hits as many compromises as possible so that the client is still able to get something to production quickly with quality testing, both of the system, the application, and the security of everything that goes with it, and balancing those compromises that are inherent in life.
There, you guys working with many customers, I guess there is like a relatively wide spectrum of organizations and their maturity level, in various of these things. I'm curious if you can speak a little bit about that.
In the last sort of 5+ years or so, there's a lot of CV++ development or intellectual stimulation over business value. These do have their place at either end of the spectrum. If something is very complex, and especially if there's a wide range of skills in the team, you can end up with this 10x developer mentality where somebody will just go and build everything and do it their own way, proof of concepts, and they may well get the business to a state where it's hit its revenue targets, it's still got loads of runway left. On the flip side, that's more likely to have security holes because there's no time to stop and breathe and consider, well, what are the potential side effects of this type of behavior? On the other hand, organizations that prioritize absolutely technically correct architecture, if they have a technically beautiful system but no customers, they will not survive in a capitalist market. The next question is, do you need Kubernetes to do that? Obviously not. On the flip side, the single process sort of function as a service model that Lambda launched, Google Cloud Run, is awesome for this. I use it for a lot of projects.
As developers, we know that there is a huge amount of open source software that we rely on. We don't even know what rely on. The complexity is enormous. So I just want to hear supply chain. It has been also a source of major attacks. So if you can share your thoughts on that.
Open source is free with no liability, but it's transferable. People can fix the problems with it, contribute them back. And actually, as an organization building software, you'll save loads of money. Of course, that is a double-edged sword. And the other side of that is there is no veracity or identification of committers into those code bases. The whole process of supply chain security is the producer-consumer problem. Anytime you modify something and share it, you become a producer. And open source doesn't attach any weight to that production. That is, of course, its massive benefit because anybody can contribute into the commons, and on a meritocratic basis, the best pieces of software will bubble to the top and be reused more, have more noise around them. So what happened then was all of a sudden, everybody who had been using open source for various reasons suddenly realized that there was potentially a problem with the supply chain. And that was nobody was verifying anything. And the only way that we would do any scanning was to check for library versions that had published CVEs in the US NVD database. Now, notably, the vendors who will scan your software these days have their own vulnerability assessment teams, so it's not as bad as it could be. But the reality is we went from everybody happily trusting everything they throw to production to we now need to trust but verify, or in fact verify before we even trust. So software composition analysis then kind of morphed into SBOMs, so building a software bill of materials. There are two trains of thoughts here. One is to have an SBOM for the immediate dependencies of your application. The other is to have that plus the transitive dependency tree that comes off the back of it. Really, compared to what we were looking at within Toto, which is hashes for everything, SBOMs don't necessarily always even require a hash these days. Standards are constantly updating and things are changing a bit. But we find ourselves pointing to package URLs that might be actually a GitHub URL with no content addressable SHA on the back of it. So whatever somebody's pushing to master or force pushing over their header revision then becomes what is pulled down. That makes composition analysis and scanning just by versions deeply fallible. So really the only way to do that effectively is to hash every dependency and to do a deep scan to look for a deep hashing of everything in the source tree to find signatures like VirusTotal and looking for known implants. But in this landscape where we've potentially got implants into open source libraries through social engineering attacks over many, many months, those are not going to get registered as 0 days until they're discovered. So software composition analysis makes no difference. So we find ourselves in a time where there's broadly two kind of solutions here. The first one is run as much abstract syntax tree analysis over the software that we're running. Check for strange patterns, check for unusual behaviors. Realistically, this is the kind of thing that centralizes in a vendor because it's a huge amount of very deep and technical work. And there are some vendors doing that with symbolic execution and instrumentation of source code so they can actually see the paths that things run through. The other, which is actually what I think everyone should be doing, is deploy things in containers with the absolute minimum set of permissions. That is, dropping all capabilities, running Linux security modules for seccomp, AppArmor, SE Linux as appropriate, and also monitoring everything for anomalous behavior so that if an application does have a backdoor or a new behavior, nothing is entirely secure and it never ever can be. So making sure that we have detections and remediations in place, purple teaming systems, making sure that SOC and SIEM systems actually find the right actually respond to the right alerts and know where in the code or which team to respond to, I think is the only way. There is, it's another form of insider threat. It's just externalized insider threats. And the only way to do that is segregation of duties, again, from an application layer, microsegmentation, and deploying things in a more difficult way and building security in from the beginning. Finally, ensuring that everything can be stood back up immediately from backup and an infrastructure as code, because expect the worst, I think is the sign off.
Semaphore has released the Flaky Test Dashboard to help you identify unreliable tests in your project. Identify which tests disrupt your pipeline and cost you the most, all in one place. Go to semaphorecI.com/product/flaky-tests-dashboard to find out more.
Are you aware, or are you seeing any efforts in the wider community of so to say, like a framework, like or a guidance, or whatever you mentioned, a Debian community, making an effort, on reproducible builds and all of that could be systematized and kind of pushed through to the open source community?
So in terms of reusable frameworks for reproducibility or for supply chain security, it's really difficult. Some of the standout examples, Nix is, as in Nix OS and the Nix package manager, is reproducible by default. Everything is hash addressable or content addressable, and you can just switch your root file system by pointing to a different hash almost. That is excellent and wonderful. One of the issues they have is vulnerability correlation. Publishing a CVE feed to link back to the actual version is getting there. That's been under development for the last couple of years, but it's not as mature as some of the application libraries that do the same. The tooling can be a little bit inscrutable. Normally, that's the biggest complaint, is that onboarding onto Nix is a little bit difficult. And of course, containers were supposed to be reproducible, but because, for example, the Golang tar implementation differs between operating systems, it's not actually reproducible, which is slightly frustrating. It's kind of not quite there. So that there are efforts in place to make sure that is reproducible, sort of fully binary reproducible. Ultimately, reproducibility also comes down to dispelling non-determinism. So are you using any sort of timestamp anywhere in your build log output? Well, you can't put that into the final artifact. You can if you do it somewhere else, but then what are you actually hashing? Are you using a different locale in one place to another? Some places sort the alphabet differently based upon local differences for accents, etc. But once you start to remove those, it's not particularly hard to get into that state of reproducibility. The ultimate question becomes, is reproducibility the answer, or is it one of the symptoms of a solution? And unfortunately, I would love it to be the answer. SolarWinds implemented a duplicate pipeline with Kubernetes and Tecton, I believe, that did exactly this, built the same artifact and tested it out of the other end. While that will detect compromised build infrastructure, it does not fix a supply chain attack, because if one of their dependencies has an implant, it's just being built twice. So there's two very distinct but commonly named supply chain issues. One is the producer-consumer problem of ingesting untrusted third-party code, and the other is compromise of build systems. Amusingly, there's a secondary angle to this, which is, well, if I have my application that consumes library A, that consumes library B, and library B has a vulnerability. Let's say it's OpenSSL and it's an old cipher. That will stop builds across Silicon Valley and everywhere that will scan and detect that and will block on a critical. Will then say, this needs human intervention. One way of circumventing this is if you look at the actual vulnerability and it says, this is in a hashing function that's 20 years old, it was deprecated anyway, then the consuming application needs to make sure that it's not consuming that signature at any point. So then, as a producer, if I'm sending that piece of software to my customers and it's already in production and they say my scanner just came back red, you can write a piece of documentation called a VEX. This is a vulnerability exploitability exchange information document. And that says, for this CVE, in this piece of software, these are the mitigations in place. We are not exploitable, and it's then incumbent upon the person sharing that VEX to, again, sign and distribute, but also to prove that out or to use the trust relationship that exists either with an open source support contract or a closed source vendor legal document. So you can actually turn the scanners green again because that piece of code is not actually exploitable. So a whole spectrum of different issues there. But ultimately, being in the case where just because something says it's a red CVE in a dependency stops production is not where we want to be out of a sense of fear, because we can still apply critical thinking to the entire project and ensure that we're actually moving software forwards instead of being terrified by the danger of the supply chain as well.
Gen AI is another thing which is introduced. Just want to hear your thoughts in the time that you have on Gen AI. What is some work that you guys are doing in that area? And
software supply chain with humans as the kind of insider or external threat makes it difficult enough to build safe software today. When we introduce AI on top of that, we're potentially introducing a non-deterministic, potentially hostile threat actor behind our firewall and then giving it the ability to make decisions without a human in the loop. Now, the gravity of those decisions is very much based on the actual application. But all of our clients have had CEO-down driven initiatives to consume some form of AI system. Banks have been using machine learning and statistical analysis for years. So everything that's not linear regression is in that space, and they know what they're doing. LLMs are very different, because it is token prediction based on words and language rather than just mathematical prediction, which most of the models are. They all have stochastic elements in them. So in the training sets, and just the ordering of the data that goes in, which means that reproducibility is not possible. When the models are actually shipped, they're so large that hashing them becomes quite expensive. We're bringing in AI, we're giving it the ability to make decisions for us, or to output code that will then be executed, to interact with APIs, to pull in data from the trusted data stores behind our firewall, and we can't tell if it's been backdoored or not. Perplexity did a study where they used their red team to insert Easter eggs into the model. If you say it's this day and use this passcode and then type this string to my response, then I'll do X, Y, Z. And where that gets dangerous is if the data that we care about is not in the model yet, but it's ragged on top by extra samples, or it's got access to those data stores. So that's very much the worst case scenario. How do we defend against that? Well, first of all, it is a case of firewalling everything that comes in. So the known prompt attacks that we have, it's like a web application firewall. It's never going to be perfect, but what we've seen with the advancement of OpenAI, it's gaffer tape and Pritt stick to just cover over the cracks for each one. We saw that with the what's heavier, ton of feathers or a ton of bricks responses. When they got patched, you asked the same question with 2 tons, and they were nonsense again. Now, the next question is in the model itself. We're throwing all this data in, and we're expecting the model to perform essentially access control to the data. That is unlikely to end well. Once the application with a model, either by it or the model itself is then performing a further action. Let's say that's calling out to a data store. So the outbound requests then need essentially reverse proxying and identifying to make sure that they are what's to be expected from a single request. Is the model suddenly returning more? There's a whole load of heuristics in there that we're running a number of different experiments on to try and understand what good looks like in terms of that anomaly detection. Because if it's too noisy, it'll just get turned off. And if it's not noisy enough, it'll miss things. So there's some tuning to do there that's interesting. That data then comes back into the model and it formulates a response, which is passed back to the user. At that point, the response has to be, ideally, if it's put into, again, a known, not necessarily binary, but a known format, put it to YAML, JSON, protobuf, or whatever it is, then we know that we can perform static analysis initially just to see if linting the thing conforms. Then there's probably a pipeline of parallel executions, some static, some to other LLMs, that are things like, is there toxicity in this? Is there an IP leak? Is there a leak of PII? Is this data actually related to what the person requested in the first place? The problem with what I've just outlined is there is a huge amount of extra compute, latency. That is a very expensive thing to do. And again, you won't see that from people trying to win a GPU-bound AI race at the moment. So the different approaches we're taking to this, first of all, we're just working on essentially educative pieces to say, this is the worst that could possibly happen. You can reduce this risk by segregating models, put different data classifications in different places. The same thing that you do with Kubernetes clusters, don't multi-tenant different data classifications, because if you do root the cluster, everything's hosed. Second of all, it is tuning those 3 stages of filtering and proxying for the actual workload and for the level of risk that is anticipated by the system. And then finally, it's actually contemplating, well, what was the supply chain of the data that got into that model in the first place? We have no idea what's in any of the open source models. They're open source in name, but not in an OSI full reproducibility definition. Second of all, it is, what about the provenance and veracity of each bit of data that has then been used to train that? We're seeing everything's moving towards RAG at this point. And so the source model that we're building on top of is that wildcard threat actor. We have no idea what's in there. Versions change. So part of our solution, and currently involved in the Finos AI Readiness Working Group, where we're looking to bring Gen AI into a bank for writing an email. The simplest use case, what is the risk? What governance do we need to be aware of? and how do we be compliant to the data security usages and requirements that we would have normally. So it's a combination of all these things. It's essentially this devastating architecture to attack, red team, and just do demonstrations on. It is trying to do something public in open source with Finos that brings everybody together on the journey and provides quantifiable security controls.
Amazing. Andy, thank you so much for talking with us about all of this. Last question for people who want to, follow your work. You mentioned the Finos,
Absolutely. You can find me on Twitter at Sublimino. And then from there, you can find LinkedIn. ControlPlane.io has a blog feed with all of the latest things. When we do talks, we put them up there as well.
Thank you, Andy, so much.
It was a pleasure. Thank you.
What a great conversation. We hope you enjoyed it and learned something new. Make sure to subscribe to Semaphore Uncut on your podcast player of choice so that you don't miss our new episodes. And stay tuned.